this evening here today. I hope the refreshments have been nice and you have been meeting, I hope you can hear me. You have been meeting new people from the iOS dev community here in Singapore. My name is Praka. It's a bit of a weird one. It's Prakhar. You can just call me Hey You. I'm a student developer pursuing a diploma in information technology at Nanyang Polytechnic, and I'll be your MC for this evening. First of all, let's give a big thank you to SMRT for hosting us here today at this wonderful venue. Yes. So, before we get started, I would like to talk about the events that we'll hold today. Let's go to the outline. So right now, we're just going to start with the first talk, and then at 7:30, we'll have another talk on harnessing the power of Kafka for mobile apps. 8 p.m., a quick Kahoot quiz. This is usually the favorite segment of the crowd. And 8:15 p.m., you can just relax, meet new people again, networking, etc. So before we get started, I would like to invite Eugene, who is our host from SMRT today, to give an address. Eugene, please.
Thanks. Yeah, so good evening, everyone, and it's a big privilege for us to be hosting you at this event today.
Eugene, can you just put this on?
Put this on, is it?
Yeah.
Okay. Okay.
Yeah. Thank you.
Yeah, great. Yeah. So again, good evening, everyone, and it's a big pleasure and delight for us to be hosting you today. And in fact, this is the first time ever that SMRT is hosting an event like this. And you might wonder why are we doing that? It's thanks to a gentleman named Julius, who's at the very back of the room. So, yeah. Okay. An event like this. And I was like, what is this about? How does it work? I said, just try it. Believe me, it will work. And I think that's all how it started, and the rest is history. And we are very proud to be able to actually be your host today and to share this space with you, and also just give a brief introduction to what we do. So I represent the Digital and Data Office within SMRT. And some of the things we do, as you know, will be the public transport business. The trains business that you take, hopefully you take the train every day, and also the bus business. But above and beyond, we also have commercial businesses like Strides and Stella. So these are the lifestyle businesses, these are the shops you'll see at the MRT stations. And why is this important is this is where digital and data really go in. We build up digital technologies, data technologies for the different parts of the businesses, including the lifestyle app that Julius and Kai-Sing will talk about, but also from a B2B perspective to support trains and different operations around it. Yeah. So just a few examples, like data analytics is some of the things we work. Engineering, we build up capabilities like even the fare gates that you use to tap in, tap out the train stations are also developed by us. Yeah. So the interesting thing here is that we are also moving into the space of lifestyle and how digital lifestyle can be a part of what SMRT offer to commuters. So while you're taking the train from point A to point B, we want to look at how we bring more value, bring more lifestyle applications to you through a digital app. Yeah. And we have recently launched or relaunched what we call the Wink app, which is the app that we have today, where commuters can actually use it to Yeah, so this is something that I believe that later we'll also talk about some of the tech that goes behind it. This is, I would say, something very new. We just started the journey about 3 months ago. So I wouldn't steal the thunder, but then with that, I'll just end my short presentation and pass it over to Julius and Kai-Sing. Thank you everyone again.
Hello, mic check, 1, 2, 3. Thank you, Eugene, for that wonderful address. We really appreciate it. So now, I'd like to introduce our first talks speakers. As Eugene mentioned, they are Kai-Sing and Julius, both from SMRT. Now, a little bit of background on the both of them. Kai-Sing is an app developer at SMRT, and he has been here for almost more than 10 months, I think, if his LinkedIn profile is to be believed. And Julius has a lot of experience, according to my brief background check. Thank you, Julius, for accepting my invitation. He has 16 plus years of experience in the industry, and he has worked at a lot of places, and he's the head of technology at SMRT. And their talk is about iOS 17 and advances in image compression. I think a lot of us share the pains of image compression. I don't know about you, but I have myself have spent a lot of time ChatGPTing and Stack Overflowing image compression, and I can learn a thing or two from them. So can I invite Kai-Sing and Julius, please? Thank you. Do you know who is speaking?
Sorry?
Are both of you speaking?
Yeah, but you speak first.
Okay. Can you put this on
Yes,
microphone?
sir. Yeah, my pleasure, sir.
This open thing, right? Thing, right?
Oh, so I just click next, is it? Okay. Okay, we start? Do we start? Do I start? I start? Okay, hello. Hey everyone. Thank you for coming over to SMRT. As Eugene mentioned, this is the first time we actually run this tech event. And I hope that in the future we can have more events with you all. And I pray to God that we don't mess up. I pray to God that there's no breakdown for this talk. And hope that you learn a thing or two from us. So this is Julius, this is Kai-Sing. We work together in the small software company within SMRT. And we hope that in the future we can really provide you with a lot of good service that you haven't seen before. So I hope we can get your support. Okay, let's talk about tech interview, because like now, whenever we do a tech interview, we probably would want to go to lead code now and try some algorithm questions and see whether we can make it right. So let's do a little bit of a type of question that are being asked in tech interviews. Here's one example. Let's say the interviewer comes to you and say, okay, I want you to reproduce this image and try to find out what would be the best representation of this image? How would you reproduce it in bytes and code? Of course, you don't have to think about it, right? I'll give the answer. Typically, in a tech interview where you are asked an algorithm, you come up with a naive answer first. And then you try to keep optimizing it, have a conversation with your interviewer. You optimize the time complexity, you optimize the space complexity, you come up with different edge cases and try to figure out what's the boundary conditions until you reach the goal. So typically, what you would do, right, in an image, is you'll probably break it down into a 2D array, right? And then you probably want to have a certain amount of bytes to represent each of those pixels. Fair? So if you have this amount of pixels available for you, you use a few bytes to represent each one. Of course, this is also what the OG people actually thought about. Many of you probably know that this is an Apple Lisa. And back in those days, right, this is how they represented image. So what happened? Well, bitmap came about because bitmap is really a 2D array of bytes. That's how it is. Here's the problem with bitmap. If you represent each of those pixels with bytes, it's going to be very, very expensive. Why is it so? Now we have a higher, how shall I say, expectation of what an image quality should be like, a good image should look like. And now, the best quality bitmap, you have to represent each of those pixels with 4 bytes. And so if you have 48 megapixels, for example, which is in our iPhones, you actually end up, for one image, it's 192 megabytes for one image. That's humongous, right? So there's got to be a better way. And obviously, people have thought about it. And in software, here's how things work. You might, in your junior years, you'll probably hear about best practices. Nothing wrong with that, because best practices tries to account for as broad a context as possible. But as you progress towards your seniority in your software engineering career, you'll start to realize that there are probably no best practices, but there are trade-offs. So we have to keep thinking about trade-offs and try to find out what's the best trade-off that would help your customer and hopefully help you also. So this is a picture of a box of tea that I put on top of my laptop. And what I'm going to do is I'm going to zoom it in. I'm going to zoom it in once more and another time. Do you see those pixelations? Do you see it? You and I know that the original image, right, it doesn't have any of these pixelations. However, after taking the picture, you will see it. So this is one way that images are being optimized today. When you look at JPEGs, when you look at PNGs, HIF, the new image formats are actually optimized for the human eye. The details that could be removed because the human eye cannot perceive, they remove it. So they change the algorithm such that it only gives you just enough for you to not perceive the difference between the original image and the image that you're seeing today. That's how they compress it. And JPEG, the thing is, the same algorithm that I just mentioned has been around for more than 30 years. JPEG has been around for more than 30 years. The thing is, in the internet today, and even on your phones, JPEG actually takes up 31% of all the images that are being served today, which means that to this day, a very advanced folks like us are actually using very old technology. As you all might know, in I think WWDC 2015, Apple announced HIF and HEVC, right? However, if you look at the adoption, it's nowhere to be found. There are reasons, and maybe we'll go through it as we continue the talk. So compression doesn't just happen to image, it happens to documents also, right? When you zip your documents, the thing is, for documents, right, you don't want to lose any data when you zip it. When you zip a Word document, for example, or a text file, when you unzip it, you want to make sure that the same thing shows up. But for images and audio, you can actually compress it, and you don't have to bring it back to its original form. So there are two types of compression, but today we'll just talk about the lossy compression for images. I'll bring you through on how JPEG compression actually works from bitmap. It might sound tricky and technical, but believe me, when I explain it, I hope that most of you will actually get it. I think it's quite easy once it's explained. Obviously, when you go online, right, there are a lot more steps, but these are the 3 major steps that happens on JPEG. I think it's good to know because HIF, the new image format from Apple, and subsequent developments of image compression, right, actually relies on the JPEG algorithm. JPEG algorithm will always be there already at this point. So here's the 3 steps. One is chroma subsampling, another is DCT, discrete cosine transform, and entropy coding. We'll go through it one by one. Believe me, it's going to be very easy. So again, as I mentioned, for image compression, right, it optimizes for your eye, right? So the eye, right, it turns out that the eye is very sensitive to light, but it's not as sensitive to color. Remember when you look at your source code, for example, you put the color, right, the RGB color of your fonts and so forth. The eyes are not very sensitive to it. So what JPEG does, right, is that it changes the RGB colors into luminance and chrominance, light and less colors. So it will use luminance to limit the amount of, it will use light and it will try to preserve as much lighting effect as possible from the image, but it will drop certain colors. So it will preserve the red and the blue, and then the yellow gets dropped. So that's chroma subsampling. And because it drops certain amount of data, then you can free up the storage space for it. Next is, I gotta skip this guy. Next is discrete cosine transform. Sounds complex, but again, it's going to be quite easy. So this is how DCT works. You can look at this image, and you can see what I did here is that from the left to right, you see a huge space of black bars and white bars. And as it goes to the right, the space gets less and less. Yeah? And as from the bottom to the top, high contrast, low contrast. Okay? So here's what you can observe. With the naked eye, right? With the naked eye, do you see this part? If you look very closely, right, there's actually details. There's actually like small details that you can observe, but from afar, you actually won't see it. Which means that, so what DCT tries to do, right, is it tries to find out from the image itself, what are the things that the eye cannot perceive. So as it finds those things out, it actually removes it. So remember earlier, I did mention for bitmaps, you can assign bytes per pixels. For this section, right, using DCT, they're all zeros. They become 0 now. So which means that you don't have to interpret zeros because they're missing. Fair? Last step is entropy coding. Some of you might have played Scrabble. I asked Kaising if he has played Scrabble. It turns out that the younger generation probably haven't touched Scrabble before. So if I can explain the logic of the game, it goes like this. The letters that most frequently appear in the English dictionary has a lower score, has a lower point. Less frequent, high score. More frequent, less score. And the idea is to balance out the game. Fair? In compression, it happens the same way. Image compression, audio compression, text compression, it happens the same way. The things that appear most often, the colors that appears most often, you use less bytes to represent the things that occurs more often. And you use more bytes to represent the colors that appear less often. And then what you end up having is then a mapping of most frequent to the least frequent colors, and now you have less bytes to represent the same image. So entropy coding works that way. And then there's always 2 steps in entropy coding. What I explained just now, the Scrabble logic, and then the second one. It's called run length coding, and basically here's how it works. Remember I said that this section will be zeroed out, and imagine your file, right? If all of these are zeroed out, you'll see 0, 0, 0, 0, 0, 0, 0, 0 all the way. But I can use those series of zeros and say 0 times 256. It's the same thing that could be interpreted by your browser or your phone, but now you use less bytes to represent the series of zeros that has been erased. So that's entropy coding. So again, JPEG compression. JPEG compression works with chroma subsampling, DCT, and entropy coding. This happens with JPEG, PNG, HIF, AVIF, and future image formats will always have this because this has been standardized already. There's no way to go beyond it. There are ways to improve it though, but the same logic applies. We expect the same logic to be applied in future compression algorithms. So earlier I did mention that JPEG still dominates the internet. Even on your phones, there's still a lot of JPEGs. Apple introduced HIF in 2015. Google and several other companies came together and say, okay, let's come up with a new version of image compression, and it's AVIF. So the reason why HIF, right, although it has been around for almost 10 years, and it's barely adopted, is because of patent mess. Here's how it works. We all want good salary, right? We all want to get paid for our effort. So the people that came up with all these standards, they want to get paid too. right? In order to get paid, every time you want to implement HIF on your hardware, you have to pay royalty to these people who actually develop it, right? That's how you make money. So there has been dozens and dozens of companies that actually was part of the HIF development. So it ended up becoming a patent mess that nobody wants to pay royalty for all these companies because they can use JPEG for free. And people are saying that JPEG is too old. There are better optimizations that could have been done. And so they came together and say, okay, let's do AVIF. So AVIF, it turns out, is that it's super complex. AVIF is open source. You can use it. It's free. The problem is this. They patented HIF, which has a lot of optimizations that could have otherwise been done on AVIF. But they couldn't do it because it's patented. So AVIF had that problem. And in order to go around it, they used a less optimal algorithm to compress AVIF. So now adoption also becomes a bit of a problem. And so Cloudinary came around with Google and say, okay, let's come up with something that will solve all the problems that we are having with images. And out comes JPEG XL, which is the newest image compression algorithm that exists today. I'll pass the microphone to Kai-Sing to continue the talk.
Oh, okay. Thank you, Julius. Hi. My name is Kai-Sing, and I'm a junior software developer in SMRT. And before I start my presentation, actually, I have a little secret to share with you all. This is my first time standing in a spotlight right now. Yeah. I'm super nervous, but I will try my best to finish these presentations. So, and also please forgive me if my answer doesn't quite reach the expert level. So also thanks to Melvin, Vina, and also SMRT to make all this happen. So without further ado, let's get started. So in today's sessions, I'll mainly discuss about optimizing image in delivery in iOS and how we can reduce the image file size with, this one. Without compromising the image quality. And also, we can enhance the app performance while maintaining a positive user experience. So, but before that, allow me to share with you some context about the Apple's adoptions of JPEG XL. So, this is the Apple's events on September 12th. So, Apple has launched the iPhone 15 series and also announced that iOS 17 will be available for download by the public on 18 September. So these are the list of the devices that support iOS 17 from iPhone SE to iPhone 15 Pro Max. So this scenes was captured during the WWDC 2.3. So Apple actually showed us a very exciting slide. You can see that if we zoom in, you can see that there is a JPEG XL sentences appear in these big white screens. So which means JPEG XL will be supported by Safari 17, as well as the upcoming versions of iOS, watchOS, and macOS, and also visionOS. So when I was researching this topic, right, I could see that Apple decisions to support JPEG XLs came with a big surprise that because nobody expect that Safari will be the first browsers to support this format co-created by Google. So why it is so exciting that Apple is now support JPEG XL? Let me give you all some context about it. Apple has only recently begun to support SVG and WebP formats in iOS 13 and 14. Yes. Okay, let's look into how Apple's adoptions of WebP. So WebP was first announced on September 30, 2010 by Google, and then it's a new open format for lossy compressions, and its file size smaller than JPEG while it's still maintaining the comparable image quality. So while Apple didn't do so, Android started support the WebP on Android 4.0 and on October 2011, and iOS didn't do so until iOS 14 on September 2020. It's like almost 9 years difference in between after Android starts supporting this format. So here comes the JPEG-XL. So JPEG-XL started its development in 2018, and its bitstream frozen on December 24, 2020. So I would say that the first stable versions of JPEG-XL was ready in 2020. So having said that, if we count right, so JPEG-XL is like still less than 3 years old from now, and yet it has been adopted by Apple starting from iOS 17. So I would say this one is very, very exciting. And sorry. Okay, so in the past, Apple was very, very cautious about adopting a new image format. And only until recently, Apple has changed its attitude and on the image formats and become more proactive in embracing new technologies like JPEG-XL. So I believe this shit is like winner chicken dinner for everyone. And because Apple support the modern technology is advancing in a faster pace. So let me pass back the mic to Julius to explain more about how JPEG-XL works.
Okay, let's talk a little bit about JPEG-XL. I promise it's going to be short. So, you know, right, we all want to have a new standard. Everyone's doing Objective-C, now we want Swift. In the future, right, somebody will come up with a new language and then we have to move forward also. The same thing happens with image formats. You have all sorts of image formats already available and somebody comes along and say, why this confusion? Let's come up with something else, and now out comes JPEG-XL. For sure, this will happen again in the future. But let's talk a little bit about JPEG-XL and what kind of problems it tries to solve that doesn't exist yet in all the image formats that has been available since before JPEG-XL has been finalized. By the way, earlier, Kai-Sing mentioned that the bitstream of JPEG-XL has been concluded by December of 2020. It basically means that let's say when you capture a picture, you have a camera, take a picture, it's a encoding process. It encodes a raw picture into JPEG, and when you actually load it on your phone, it decodes it. Encode, decode. So what he's trying to say that the bitstream is frozen, right, is that the encoding algorithm for JPEG-XL has been frozen already, which means that it's ready for use. Yeah. Okay. So once upon a time, probably when some of you are not yet born, there's only one size of the image. Back in those days, there's no responsive web, there are no mobile phones. Of course, now there are. Not only do we have mobile phones now, you have iPhone 4 with Retina display, and now you have Retina HD, right? In the future, probably there will be some Retina Super HD, yada yada, right? And so, because of these things that are happening in our industry, now you want to have 3 images, right? One for each pixel density, correct? So you have 1x, 2x, and 3x image, correct? So this becomes a problem because then you want to have 3 versions of your images. Like, I mean, it's a lot of work, right? For your designers, for your developers. What if you miss an image? What's going to happen? It loads slowly. So JPEG-XL is actually attempted to solve this. And I have to say, it's quite good the way they do it. So let me explain a little bit. Maybe before I explain, now when you load an image, right, on your apps, you probably want to have a placeholder, right? Maybe a shimmer. And then when the image is loaded, the image shows up. Wouldn't it be nice if we can gradually show the image as it's being loaded? So then the user experience would be better. So JPEG-XL actually does that for you. So here's how it works. Here's an example of a full-size image. And here's what's happening with JPEG-XL. I'm going to slice it in half and slice it in half. I'll do it again. Slice it in half and slice it in half. And you see what's left here. I'm not sure if from the back you can see. There are some artifacts. There are some artifacts that are left over. So I can actually expand the small image by applying those artifacts to turn the image into this type and apply the artifacts below to blow it up. Yeah? Which means that if this algorithm works this way, I can repeat the same algorithm and repeat the same algorithm and keep repeating it for as many sites as I want for JPEG XL and blow it back up. Yeah? So which means that I can actually load a very tiny portion of the image as things are loading and slowly make it clearer as enough bytes are available. So this is one thing that JPEG XL does that previous formats, right, apart from GIF, is not able to do. Hence, it makes life easier, right, for developers because once you have JPEG XL, one image, that's it. Yeah. Another thing that JPEG XL is doing very, very good at that has never been done since JPEG was, I guess, finalized, is this. HIF, AVIF, WebP, all these formats, right, are video codecs. They're video compression algorithms. And so what they did was, from video, they pulled out the image compression algorithm and applied it to image. So they started with video, and they ended up with image. What's the problem? The problem is this. So imagine I'm moving my hand like this, and you can do it yourself also. You can see that your hand, as you move it like this, it becomes blurry. When things are moving, it becomes blurry because your eye is not able to follow the speed of movement, which means that for video, I can actually compress the image more because you don't have to see a super high quality of the image if it's moving. So it's blurry. In the same way, AVIF, HIF, and WebP, they all have this problem that JPEG XL don't have because you start with JPEG. JPEG XL based its compression algorithm from JPEG, which means that it doesn't have all these artifacts that it cannot remove because it started with video and ended up with image. So that's how JPEG XL works. There are actually a lot more behind the scenes, but I think these are the two that would be exciting for the developer community. I'll hand it back to Kai-Sing to share a bit more about how we actually implemented all these compression formats.
Thank you.
All right, I'm back. So thank you, Julius. Okay, let's dive into some of the history that image format supported in each of the iOS release. So initially, iOS support PNG and JPEGs by default, but before iOS 11, the recommended image format for iOS is actually the PNG. And then, however, starting from the iOS 11, Apple has introduced a new iPhone photo format, which is called HGIF. So the long terms, the full terms is like high efficiency image format. Yeah, the reason why Apple uses it is because that it uses lesser space, and then it still can maintain the higher image quality than the JPEGs. So Apple started supporting WebP in iOS 14 as we discussed earlier, and iOS 16 for AVIF, and now we got JPEG itself in iOS 17. You can clearly see that the adoption rate for Apple's right is increasing, starting from iOS 16 to 17. So next, depending on the platform you are working with, the challenges might be different. So these are the 5 challenges that we made during the development of our Wing Plus applications. So each of the components will either affect the user experience or impact our application's performance or increase the development complexity, which leads to a longer development time. So let us take image size as an example, how a mishandled image can impact our application performance, load speed, and also potentially create a poor user experience. So we all know that a larger image takes more time to download. So in this slide, you can see that this one is our Wing Plus applications homepage. So in the second row of the collections view, you can see that the Comic Connect image is taking some time to load, and this delay is due to the large image size. Why would I say that? Let's discuss about how we design this image view. So in our design, maintaining the aspect ratio is so important because we aim to achieve the same look and feel in both of our Android and iOS device. Hence, our UI/UX designers try to fix the width and height into 200 points and 200 points and 110 points. Why I'm using points as the unit for width and height here, it is because in iOS coordinate system, there is a mapping relationship between points and pixels. So for example, in iOS, 1 point equal to 1 pixels in a standard resolution screens, and 1 point equal to 2 or 3 pixels in a retina display. So they would say that maximums of 600 pixels in width and 330 pixels in height is the optimal pixel dimensions for this image view. So let us look into these properties, the properties of this Comic Connect image. So you can see that this image has a huge file size of 1.3 MB, and it has a pixel dimensions of 2,700 times 1,100 something, and which is super huge. And when we compare that, the pixels dimension that we actually want is 600 and 330 versus the dimension we actually download, it's like totally overkill. We don't need this much of pixels. And downloading unnecessarily image details not only impacts the app performance, but it also leads to the user frustrations because it takes a lot of time to load it. So how we can fix this? So there are lots of image manipulation solutions in the market like Ingit, FileStack, Cloud Image Kit, and Cloudinary. So for the purpose of this talk, I will take Cloudinary as our reference implementations. So what is Cloudinary? So it's an end-to-end image and video management solutions for web and mobile applications. So you can notice that here are the 4 features that we are using to optimize the image. So I will focus on these 2, the image transformations and image format conversions features, to how it can help us to decrease the file size and also while didn't impact much on the image quality. So yeah, okay. This video shows how a mishandled image can impact the app performance. So for this video, I have created a lazy horizontal grids to look this adorable pins image, right? You can see that the file size of these images is like 2.45 MB each. I didn't do any optimization yet, so it is huge. So you can see that it's very lag, right? When you scroll through the horizontal grids, and this lag I can say is due to the large image size. And to fix these issues, we'll make use of these 2 features. Okay, this one is the video. I have applied the image format conversion features. So you can see that the image size in these pictures, in this video, actually reduced from 2.45 MB to 0.5 MB. However, the lagging issues still persist. Oh, thanks Siri. Okay, so in order to fully optimize the image, we need to we can further optimize it using the transformation features, which allow us to resize the image to the desired dimensions. So you can see that in this video, the lagging issue has been fixed. And the file size has been reduced from the original 2.45 MB to 0.03 MB. Yes, it's like almost like a thin A. So how here comes the implementations. It's very easy. So first in the port file, we include the port coordinate and set the versions to 3.0, and we run the port install in the terminal. Then we will create a manager class to handle this, and I'll make it a singleton. Next, I will create we need to configure initializations, and you can see that in the red box, right, there is a cloud name there. Okay, this value you can get it from your Cloudinary account after you log in. Next, which is the last step, we need to create functions to set our default image type. So and we need to call these functions in our initializations functions. This step is to set the image format to your desired format based on the user device operating system. So this is the functions that helps in generating the image URL that Cloudinary server can understand. So we need to pass in the public ID, the width, height, and image format. If you want a customized image format, you can pass in. Then, so what is the public ID I mean here? So it means that it refers to the image files name that you store in the Cloudinary. And you can notice that in this line of code, it set the transformation rules, which resize the requested delivery image from Cloudinary to pixels dimension we specify. And this line of code is used to set the image format conversions rule, which convert the image format to what you want. So you also can further customize these rules based on your needs. In this demo, I'm using these functions to demonstrate the image quality and also the byte when we download the image from Cloudinary. So next, we will need to create a view. Okay, then we fetch the image from Cloudinary using the function that we created earlier. So we need to define the width and height for the image that we want. And next, in the body, we will need to call the functions that we created just now to get the image URL. Then we pass in the public ID and width and height that we want. Next, I will create the vertical stacks, and inside the stacks, I will create an async image and pass in the image URL that we generated just now. And yeah, that's it. Okay, you can see the very, very cute cat here. And below the cat, there's a URL image, image URL showing there. Yeah, this one. Okay, you can see that this URL has some parameters like cfields, hash, height 1,200 something. So these are the parameters that we send to Cloudinary server so they can understand how they need to transform the image. So now we will discuss about the image quality and the image size that before and after we perform these optimizations. Yes, I believe this one is too small. So, yep. So, yeah. In this slide, I'm showing three cat images here. One is the original, in the middle is with the transformation. In the middle is the with format conversions, and last one is with both optimizations. So, is there any difference between these three images? In technical terms, yes, the appearance might be different, but from the user perspective, obviously, I don't see any difference between these three cat images. However, if you look at the image size, the difference is huge. So how much file size is different and how much bytes has been saved by using these optimizations? So the file size you have seen in this slide is a result of both image format conversions and also the transformation features being applied. So I have made a comparison with some of the popular image formats such as WebP, HEIF, RVF, and JPEG SL. So you could see that there is a very, very interesting result showing here. The most byte saved is actually the AVIF format with like 95, I think 98.77% lesser than the original file size. So you guys still remember this one? This is our current implementations in our Wing Plus applications and on handling the image format. So if you notice that on the last one, the last functions here, we are actually using AVIF for iOS 16 and above and HEIF for the rest. So although iOS 17 has already support JPEG XL, but why we are not using it now? We could just apply the code on the ideal scenario like JPEG XL for iOS 17 and AVIF for iOS 16 and HEIF for the rest. But why we are not doing it? If we look back to this slide, by safe image optimizations, we can see that on the bottom right, you can see that the file size of JPEG is actually bigger than the AVIF. So it's very, very interesting because by right, you research online, right? Theoretically, JPSL is like 11% smaller in file size and 30% higher image quality than AVIF. But yeah, this is the result that we get. That's why we stick with the AVIF for iOS 16 and 17 for now. So I think that's all from me. As a fresh graduate, which has a 10 months of experience as a software developer. So actually, I used to think that it's very, very excited to build a lot of fancy things like CDN, Image2, and also other big complex projects. However, I've come to realize that as a software professional, that our job is to get to help the business run smoothly. So with this perspective, we always face a choice. Should we spend all our time in building the projects from scratch, or should we just buy an existing solutions? So in our projects, we decided to buy, and it worked out great, and it helped us to deliver the features faster and avoid all the headaches maintaining a large technical projects. So the key lesson I have learned here is that sometimes it's wiser to buy instead of building everything in-house. So yeah, I think remember what Jobs once says, stay hungry and stay foolish. As a software developers, although we choose to buy this time, it doesn't mean that I have lost my enthusiasm in software development. We can stay excited about new challenges and also maintaining our curiosity while exploring innovative ideas. So in this way, we strike a balance between being practical and keeping our passion alive. I hope you find this perspective helpful. Thank you.
Thank you.
Maybe we can let them know that the toilet is right next to the entrance.
Yeah, sure.
Thank you, thank you.
Okay, so first of all, can we have a round of applause for Kai Singh and Julius? Incredible talk. Thank you very much. Also, he wanted me to let you know that the washroom is near the entrance, if you want to go. Okay, so next up, can I welcome, I hope I'm pronouncing this right, but Chiran, GV, and Subhranshu Behera to the stage to give the talk on using Kafka for mobile apps. Hi. We'll be speaking first. Sorry, which one? Who is speaking first? Can you put this?
Hello, good evening. How many of you have heard about Kafka? A quick show of hands. Very few. How many of you have used it? Okay, Desmond, yeah. So, as some of you might know, I've been doing iOS development for close to 10, 12 years. Then I moved to backend about a year ago, and Kafka was the new thing that I needed to learn. And now I found it really fascinating to a point that I thought, how come we can use some of these features in mobile apps as well? So we'll be talking about some of these use cases today. Now you see part one here, because this is such a big topic that we cannot cover in one talk. So we'll be covering part one today, where we'll be giving you a little bit of introduction on Kafka, what is possible, what is not, and how does it compare with other solutions which are there for mobile applications. Then part two, we will dive a little bit deeper into some of the demos. So this is the agenda for today. We'll be talking about event-driven architecture, Kafka, use cases where Kafka could work for clients. And when I say clients, it's not just iOS apps. It could be a Mac app, it could be a TV app, it could be anything where you can run Swift, but you can still make use of Kafka. And what are some of the challenges? Then we'll be doing some comparison today with the pub/sub mechanism, MQTT, and WebSockets. But there is this thing called Kafka REST. We'll be looking into that in the next talk. So let's dive into event-driven architecture. Now, I don't know how many of you have done backend development, how many of you have known enough about backend development. But let's say you want to build an app from scratch, both client and server, or you're starting a startup. 10 years ago, you might have used this approach. The left-hand side, you have your user interface or your client, your mobile app. The centerpiece is your backend, and it can be one server, and you have all your logic there, your data layer, your business logic, everything in there, and some sort of database or data storage. Now, as I said, if you build a startup, if you start as a startup today, you might be using this approach, and there is nothing wrong with it. But this is a simple enough approach. For bigger organizations, as you know, there are so many different modules. Now, we'll be looking into an e-commerce example later on. There's so many different modules. There's so many different services. Now, managing all these services into one server is challenging. Challenging in terms of maintaining them, troubleshooting them, and let's say you have a client app and you need to just make some changes to one of the service. You need to put the entire server down and your app goes down. So all these things become challenging. So that's where the microservices-based approach came in. But when people started using microservices-based approach, they started using APIs to communicate between each of these services, usually REST APIs. So your service communicates with another service using REST API. But this approach also has some problem because it's very tightly coupled. You need to basically wait for sometimes the response from the API. In async method also can work. Then people started using message queues. Now, message queues like you can imagine your push notification. Let's say you have a push notification service and you need to send push notifications to, let's say, 100,000 or a million users. So you build a queue, you send all this notification one by one from the service, and all of them stay in a queue. But what is the problem with this approach? First of all, if you just go with one queue, there is a single point of failure. If the queue goes down, everything in the queue gets lost. And there is no persistent in this kind of approach. So that is where people are moving towards this new thing called event-driven architecture, and Kafka is leading that domain right now. And we'll be looking at some of the use cases. As I said, the e-commerce application, let's say this is a monolith application, and there's a client, and let's say there are three main features of the e-commerce application. There's the catalog, and order, and payment. Now your boss comes to you, let's say you are the developer of this, you recently joined this company, and boss comes to you and tell that, hey, we have this monolith applications, now change it to microservice-based application. Now you won't change everything at one go. You'll start to find something that has the highest number of feeds or something which is very critical and change that to a microservice. So the first approach is maybe because a catalog is something that gets viewed by users a lot of time compared to your order or payment. Let's say phase one, you moved only the read part of the catalog into a service. Write still happens to the older service. However, read is happening with a separate microservice. In full replacement, you can just move out the catalog, and read and write both goes to that particular service that you built. Similarly, if you want, you can move order out of this. You can move payment out of this. There are several advantages to it. Now, these are some of the testimonies from people who have used Kafka in production. Now, when I'm talking about this is in the backend for sure. But if you see, there are two testimonials I'll highlight. One is from eBay, Korea, and they say that they have reduced their go-to-market time by half just by using Kafka. Now, what does go-to-market means? Let's say somebody tells you a product, how long it takes you to develop, test, and really go to market to your users. So they have reduced it by half by using just event-driven and Kafka architecture. So another asset management companies, they said they needed to wait for a day to receive data logs now they can receive all this data in seconds. Now what they do is the data is completely up to them, but now they are receiving data and receiving events in an almost real-time manner using this event-driven architecture and Kafka. Now I'll ask my friend Chiran to tell a little bit more about Kafka and dive deeper into Kafka. I'll come back and say a little bit more about the mobile use cases. Chiran.
What is it?
I think we have to do this, yeah.
Hi, hello friends, good evening. I'm Chiran. I'm working as a backend engineer in SP Group. I'm mostly doing backend stuff, almost more than 10 years. Like yesterday, Sub asked, like he's planning to give this talk. So if I can share more details related to Kafka that we are using in backend. Okay. So before jumping deep into the Kafka, already Sub mentioned that let's say for example 2 different systems wanted to communicate. Okay, it could be like submitting an order to, let's say, system A capturing the order, system B need to do a payment for that order, right? So when these system calls, predominantly if we use HTTP, say for example, to make this successful, both the systems has to be up and running. Okay, assuming system B that is that has to take care of payment processing is down, at that time if this order capture try to call the payment system, of course a failure happens, and then this order capture system has to do multiple retries, right? So what is happening here? Here 2 systems are tightly coupled. Whenever we say HTTP, right, or it could be even WebSocket or whatever, right, 2 different systems, when it is tightly coupled, problem is it is not going to be fault tolerant. If any failure happens, we are losing that event, and then some retry mechanism is going to take place. So what is needed? We need as much as possible any flow, if we can decouple, and let's say in this case order system can just say, hey, please process the payment, do not wait further, so that this particular message, if it is lying somewhere, and then the payment system can then read this message and then process the payment, and then says, hey, I have processed the payment later, right? So when we do this decoupling, what happens, what benefits we are going to get is that this particular mechanism can be extended as a distributed architecture. Okay, so maybe you can go to the next. So you can see basically you can see lot many sensors are there in this each and every floor of the building. Likewise, we have many buildings, right? So we will be having multiple sensors, say for example, and then each and every sensor may need to transmit some kind of data, okay, which in this case sensor is acting as something capturing and producing, okay, and then it needs to send it to system which actually does some analytical, say for example, right? So all these sensors are forming a kind of, you know, distributed sensors basically, and then what happens, like the processing also, like data from one particular sensor may need to be used for various purposes, right? So at the consuming side also there could be multiple systems. So so here you can see what Kafka does. Before Kafka, you see the MQ, right? The MQ is not supporting distributed systems well because of one reason, that if you see MQ means whatever the message sent to the queue can be consumed only once, and once consumed, that is deleted from the queue. That was before 10 years back. Now Kafka is an enhanced one that what it does is it helps accepting events from many producers and then send these things to a consumer who is actually parallelly processing all these events. Okay, so maybe you can go to the next slide. Yeah, so what happens this way, when we remove HTTP and go into this decoupled approach, what happens is we could process multiple messages at a given point in time by simply adding more producers and more consumers. Okay, so by scaling it up, what happens is whenever load is more, the request is more, at that time we can add more servers and then we can consume them. Whenever there is no request, then we just shut down, scale it down so that we will save some resources. So that is the throughput is one good thing for Kafka, because it is like it can allow many producers and consumers to be there, and scalable we just covered, and permanent storage. So what happens in the older approach, only when we say the message queue, the messages are losing, means we can lose the message after processing, but later if you say for some reason we wanted to replay the whatever happened to the events, right? So that one we cannot do it in the older approach, but now in the Kafka side we can actually replay n number of times whenever we wanted to see what happened. Let's say on this day what happened, we can actually go back to that particular time in and then we can replay and see what had happened. Yeah, and high availability, because so if you see Kafka, right, we have multiple servers. We call it as leader plus followers. So each and every Kafka instance will be running in its own nodes, and all the nodes are connected, so that if one node fails during this processing of the messages or events, all other nodes can actually take care of the further processing of the messages. Next. Yeah. Okay. So so Kafka is, it has lot many things. Let's say for example, an event is produced, but if you wanted to filter down some events before processing at the consumer side, they provide lot many built-in processing libraries, and it can be like, as of now I am not sure about the front end library. Can actually Sub is trying to make this library to from the front end device to Kafka. This part is not there, but apart from that, if you see any kind of device can actually using the Kafka libraries can connect to the Kafka broker and then start sending the events or messages. Yeah. So Kafka use cases. So basically we already talked. It could be like yeah. So when we say complex system, it could be at, let's say take an example of trading platform, right? So when a stock is like when a user wanted to purchase a stock, when we say buy this stock, it's not going to immediately buy the stock. For this, it has to undergo a complex process. It could be first validate whether the amount given to the stock is within the range of deviation or not, and then it can go further, like user is having balance to buy this stock, whether the stock price currently how much it is, and then that message has to go to the respective exchange to buy the stocks and all, right? So it is a complex process. So within a company there will be multiple systems, and all these multiple systems actually coordinate together using Kafka, and then it's kind of event-based processing can be achieved in an asynchronous way. A lot many, yeah, and I think lot many Fortune companies are using this one. Netflix, Uber, collect real-time user taxi or trip data. Yes, LinkedIn for using it as a light version of the Kafka, mainly to capture spam or real-time user interaction. Scam prevention you mentioned.
Yeah, that one is. I think the example here are mostly for backend. LinkedIn also uses a lighter version on the client, mostly for tracking user activities, like when you like a post or when you comment on a post. So for those kind of things, LinkedIn is using, and I'll talk about some more use cases of client after a few slides.
Okay, so there are a lot many technical details. I won't bore with all of the things. So major things, Kafka's main thing is topic, that you can see the third one, right? So this topic is going to form a logical channel between producer and consumer. Okay, so this topic is going to have all the events or messages a producer wanted to convey to the consumer. Okay, and so on the top first you can see producer is nothing but the one who wanted to send some instruction to the destination, and broker is here a centralized not a centralized, sorry, a distributed Kafka servers connected. It could be like spread across multiple availability zones, so that like all the brokers together, irrespective of one of them or a few of them going down, forms as a cluster, and then they ensures that whatever producer given to the broker reaches to the destination without any failure. Okay, and consumer is nothing but the one who is going to actually receive the message and then do the action, whatever specified steps needs to be done for that particular successful processing of the message. And partition, basically, let's say for example, since we were talking about distributed processing, that is, whenever millions of requests are going to come, right, one processing them is not at all sufficient. Basically, we need to scale them horizontally, so that like we can do parallel processing, in short. So this partition is going to help the horizontal processing, so that like millions of messages can be processed within a minute or so. And you can see offset is mainly to keep track, like to not to lose any messages from the consumption at the consumer side. So let's say for example, a message is consumed, and then a problem happens at the consumer side. When the consumer restarts, it needs to know from where the message has to be processed. So for that purpose, the offset will be used. And we can also say consumer groups. Mainly we can form groups. Consumer groups is nothing but it has more than one consumer in it. Why it is needed? Say for example, when we say partition, that is, we are splitting the topics into n number of partitions, so that we can allow n number of consumer to process parallelly. That is the purpose. So partition and consumer groups go in hand. And then retention. Why retention is needed? Basically, we will not lose the message. We can specify how long we need to keep these messages. In fact, Kafka, with respect to Kafka, these things are not even messages or events. The first priority given to they are considered to be a log. Kafka has a log. Whatever sent by the producer is first logged, and then only it is transformed into events or messages to the destination. And we have so many connectors is to mainly to for different languages. Kafka is having different connectors, and they act as a producer or consumer. Yeah. So here you can see that you can see lot many producers are there. Let's say you just assume the trading platform, right? Lot many order producer. It could be like, let's say in Singapore, maybe some 100K users purchasing, right? So at the time, in a given minute, it could be thousands of transaction, right, orders for that trade. So the producers are, let's say, though from the front end side, it is going to call one of the endpoint to the back end, and the back end side, what they can do is they just accept the trade request and submit it to the cluster using one of the producer. So now, why we need many producer? Basically to handle more throughput. If we, let's say when we wanted to process 10,000 message per second, we need to have more producer to accept the message and hand over to the next stage, right? If let's say just 1 minute, maybe 100 requests, we just need one producer. Similarly, consumer side, if we wanted to process, let's say similar number of like 10,000 requests per second, we need to have more consumer to consume them and then process. Yeah. So this is a distributed architecture. You can see microservices. What we just spoke is like order service or payment service. All those things comes under the microservice, and then there could be like some monitoring stuff, which could be something like Datadog. They also may need to capture within the system and send it to the Kafka, or even this monitoring could be related to this sensor metrics event, right? So the requests can come in various form, web requests or apps. All of them as of now won't go directly to Kafka. As of now, it will go via some of the microservices, and then through microservice it goes. But the future Sub is trying to do is like how to harness this direct communication from all the devices to Kafka. That is the thing. Yeah, IoT device, all these things we already covered. Types of events. Yeah.
Bit overwhelming, isn't it? Like too many things to know and discuss about. But if you see what we do from a client point of view, from a mobile app point of view, or from a Mac OS app point of view, most of the things that we do are transactional data, right? We make an API call, we get a response, JSON response, we parse and we display in the UI, right? But Kafka is not just for transactional data. Transactional data is just one part of the things that Kafka can handle. There are a lot of other things like logs. You'll hear logs a lot of time because log is a big thing. Real-time data is like for monitoring system, for IoT devices, user interactions. Today we are using Google Analytics or Firebase for these things, telemetry and monitoring, and a lot of machine learning data, right? You could be sending some data from your mobile app to some form of business data lake or something, and they will be doing some kind of analytics on top of that, right? So all these are events that you can truly use Kafka for, right? So use cases for clients, right? Now, if you see, can you use Kafka for everything in client? No, you can't, because it's not there yet, and there are various challenges for it. But what can you use it for? If you have used any sort of Crashlytics, or if you have used any sort of user analytics or monitoring tools like Datadog or Sentry, you know that whenever something happens, like they track it and store it offline, and they do batch upload. It's not instantaneous. They do just batch upload. It could be in 1 minute, it could be 10 minutes, depending on the resource and depending on so many various things, right? So Crashlytics and user analytics is one, but would you do it for everything? May or may not be. We'll see when you can use it. But fraud detection is another thing. You know, there's a lot of scammers these days and trying to install malwares, and suddenly all your money is gone from the bank account. Could you track those activities? Could you track those activities real time? Because if you're just tracking it using Google Analytics, you won't be looking at it real time. You will be looking at, I don't know how many companies look Google Analytics every day. I know my company doesn't, right? We look at some user analytics like maybe once in 2 weeks to see how users are behaving and everything. But if you have some kind of monitoring tool to detect fraud activities, like these can be just events sent from the mobile device to Kafka, right? And then you do the analysis on the server side and do fraud detections. Any sort of sensors, when I'm saying sensors, it's not just IoT devices. It can be BLE devices. You know, recently we had the trace together token, right? Trace together token was sending information to all these devices, right? So it could be a heart rate sensor that you're wearing, a Bluetooth device, right? Or it could be some other form of sensors that communicates with the device, but it could be critical. So for example, there are certain countries where the patients need to wear this device to monitor their blood glucose level, their SpO2, their real-time heart rate monitoring, and all those things. Even if you see Apple Watch, today they market it so much that we can tell when your heart rate falls below a given threshold, right? I don't know what protocol they're using to send the data, but technically they can use Kafka for this. Any sort of recommendation. Now, recommendation is going to be very useful if you think a TV OS point of view. Let's say you are watching a series and suddenly you see the cloth that a particular your favorite hero or heroine are wearing just beside the app that you can purchase immediately from Shopee or Lazada, right? So that could be a use case, right? And a lot of offline use cases are there. It's like you're in the tunnel, there's network connectivity issue, you store in the offline, and when the device comes back online, you send it to Kafka. Peer-to-peer gaming is another thing. But obviously there are challenges, which is why probably it's stopping a lot of people from adapting it full stream. But I believe that for some of the use cases at least, they would try Kafka. And if you go back to this use case, right, producer and consumer. So your mobile device, if you think primarily from an iOS app point of view, it can never be a Kafka consumer, but it can be a Kafka producer. So producer is something that is producing the event. Right? It's producing the event and sending to the sending the message or a topic. Right? Why it can't be a Kafka consumer? The main thing is battery usage. Because if you keep on running it, whether foreground or background, it's going to drain the battery. Data privacy and security is there, but it can be handled. These are some of the challenges. I'm not saying it can't be handled, but some of the challenges. For example, somebody is producing the data. Can somebody else see the data? And what are the various ways we can avoid it, right? Similarly, other things that I mentioned on the right-hand side are challenges which needs architectural design to make sure. Let's say the offline use case that I talked about as a benefit, right? That can also be a challenge. For example, if you haven't designed it properly, your data could be out of sync. So that could be a big challenge, right? Now, in the beginning of my talk, I told that there are other ways we can achieve this. So what are you trying to do? We are trying to send some sort of events asynchronously to the server, right? So we have WebSocket. We have WebSocket that has been there for so long. So what is the problem with WebSocket? Has anyone used WebSocket on mobile apps? Any? Okay, Veena has used for sure. The biggest challenge of WebSocket, because it needs a persistent connection with the client, right? That connection can get dropped for various reasons. It could be a firewall rule. It could be an antivirus running on the server. It could be something as network connectivity. It can kick that connection out. And when it happens, you need to establish that connection before sending any messages. So that's the biggest disadvantage of WebSocket. PubSub. So before even Kafka came out, a lot of taxi booking companies were using this publisher subscriber mechanism. So that means you will, I'm not sure, I don't know whether you're using in Grab or not, but possibly they could be using some sort of PubSub or Kafka, right? So same concept, but the challenge here is there is also a broker, but the broker here also can become a single point of failure. By design, in PubSub mechanism and traditional PubSub mechanism, they haven't thought of scaling the broker. Of course, you can scale your own broker. You can spin up as many brokers as you want, but it is inbuilt. It is baked into Kafka's system that, as Chiran said, you can have multiple brokers. If one broker leaves, you can have another broker as the leader, and so on and so forth, right? MQTT. MQTT also tries the same thing, PubSub mechanism, but MQTT is really for telemetry use case, like for your IoT devices. It's not meant for the scale that Kafka is talking about, like millions of data. For that use case is not possible, right? I saw a very quick demo on my laptop. It's running. It's not a sweep demo. So that is where I'll end the talk. But part 2 that we're going to cover next month, as Chiran said, we're exploring this from the client side point of view. There are, have anyone used Kitura server-side swept? No? Kitura is, I think, one of the library. I think IBM is the original author of Kitura. There is Kafka Swift for Kitura, but we are trying to explore from a client-side point of view and see whether it is possible to produce a lot of messages from mobile apps and for some of these use cases, right? So we'll look into this library. One is called Perfect Kafka, which is being recommended by Confluent, the company which leads the Kafka initiative now. But as you can see, there's not much traction now, right? But there's also something called Kafka REST. So what Kafka REST does, Kafka REST is a REST proxy on top of Kafka cluster. So you still use REST, but you can leverage the power of Kafka, right? But for today's demo, what I'm going to show, so I have Kafka running on my, Kafka server running on my laptop, maybe. I think I can use this one. So the server is running. So what we need to do, we just create a topic, right? So I have some alias already set up. Let's say okay, this topic already exists, so I need to so this is the producer. So this is what is going to send events to the consumer, and I'm going to create a consumer on the side, Kafka consumer, right? So these are some of the things that I had created earlier, but let's try new things. Right, so you see the message is coming on this consumer on the left hand side. Let me create one more consumer. So you can see I can roll any number of consumers who can listen to the event that producer is producing. So in the beginning of the talk, as I said, we are not looking at mobile device as a consumer, but as a producer. So talking about the use case of logs, let's say you're using any sort of monitoring tools, right? You're using Datadog or Sentry or any other sort of monitoring tools. And something mission critical fails. Would you like to wait 1 minute, 5 minutes, or whatever that the Datadog or all those tools don't guarantee, because they will do batch processing, or would you like to receive those messages instantaneously, right? So that's one thing. The battery problem, the battery use case I told is there in the mobile device, but if you look at Mac OS apps or if you look at TV OS app, the battery problem is not going to be there. So this is one way of thinking for what kind of use case you can use Kafka in the mobile app. It won't be suitable for all sort of things that we are doing, because our mobile apps today, that the way we are building, it is very much API driven. It's very much, we make an API call, we show the data, show the response on the UI. But if we have to tweak that UI a little bit, for example, let's say we make a payment and we show the status that payment is processing. Yes, in that case, Kafka could be used, right? But in the next talk, what we are going to do is we are going to try a few use cases which is a little bit more sophisticated than what I showed today, and see how far we can push it and compare it with some of the other things that we showed today, which is which is like WebSocket or PubSub or MQTT, and how does it compare in terms of uploading logs or sending events? How does it compare with it? If you have any questions for us, me or Charan, you can ask now. But I highly recommend you to just read a little bit about Kafka, because it's a very interesting thing. I think it's something that is going to come up one way or other for mobile device in a year or two. That is my gut feel what it says. Yeah. Thank you.
So I just want to make an announcement, like if you're someone who is interested in security and identity, like how to build your own, how to build your identity, what are the things you have to know, what is JWT, what is OAuth, so much boring stuff, but that will be done in a very nice way. This is mostly about evangelizing the security, what the developers, as like whenever you're building a product, what are all the things that you have to know, if you have a refresh token, if you have an auth token, access token, how do you handle it, kind of stuff. If you are someone who has some information that you wanted to share, like you want to build an app, it doesn't have to be Auth0, it can be like Firebase or any other Fusion Auth or any other products. But if you want to share the best practices, reach out to me. You can speak in the meetup. But more than that, I wanted more people to show up and then come here and then learn about the identity and security. Things are changing a lot, but we as developers have the highest responsibility of to give the users the best experience. So the meetup is going to happen in person on October 31st in our office. In the meetup page, if you go and then search for Identity and Security Singapore, you can find it. maybe I'll leave my card there. If you want, you can. I left some stickers there, or 0 stickers. If you want, you can grab it. I'll leave my card there. If you want, like, you can catch up with me, and then we can talk about it. You can find me on LinkedIn also. So that's the announcement I'm making. And if you don't know, October is the cybersecurity month. So this is all about security and the identity. So do come to the meetup, and then let's have some fun. Thank you so much. Thank you.
Okay, thank you. Do I need a mic?
I always forget it.
Okay, in the meantime, do join the Kahoot. Wait, I have a jacket. Okay, is it good? Okay, so I'll give another 5 seconds. 5, 4, 3, 2, 1. Okay, let's get started. Give me a second, let me find my cursor. Oh, there's my cursor. Okay, so let's get started. We ignore the staring. Okay. So first, a poll. Do you use SwiftUI at work? Yes. I love UIKit. I don't work. No chance to use. It's complicated. Or I don't do iOS development. I'm here for pizza. Okay, so interesting to see that quite a few people are actually using SwiftUI for work. Okay. Good luck to the 3 people here for pizza. Hopefully you got your pizza. Okay, so word cloud. So can you describe this meetup in 1 word? There'll be an image later, but this animation takes a while. See, this image took like longer than I would expect to upload. So describe this meetup in 1 word. 1 word, not like the last time. Okay, so let's see. Good. Compression. Yes. Ooh, pizza. Ooh, interesting. Okay, so glad that everyone kind of enjoyed it overall. I think there'll be future meetups that you can come by and definitely get pizza. I think, Vida. This is on you now. Okay, next. So now real quiz questions. Which frameworks allow you to train ML models locally on iPhone? So this isn't that new. This came out last year actually. So the capability came out last year to train ML models locally on iPhone. So is it Core ML, On-Device ML Kit, Create ML? No, what are you, crazy? Why would, whatever, that thing's too long. Train ML or On-Device ML? So it is Create ML. So Create ML came out with the functionality to train ML models on iOS last year. So starting with last year's version of iOS, you could actually start training locally on iOS. I don't know why you would ever do that, but it is an option. Okay, congrats to Dragon Star. Okay, multi-select. Which versions of Xcode can be used for Vision OS development? Xcode 15, Xcode 15 Beta 8, Xcode 15.0.1, or Xcode 15.1? Okay, so it is actually only Xcode 15 Beta 8 and Xcode 15.1. Xcode 15.0.1 does not actually support it, and Xcode 15, which is currently on the App Store, is the release version, does not support it yet. So congrats, Siram and Tim Cook. Oh, hi, Tim. Okay, what frameworks allow you to expose your app's capabilities to system services on iOS? Is it System, App Intents, Shared Groups, or System Extensions? Yeah, so it's app intents. So app intents are used in everything from Siri to shortcuts to Siri shortcuts, Spotlight, widgets. all of those allow the system to interact with your app. So congrats, Siren. I see that Kai is no longer here. Oh, which of the following is new with Xcode 15 in XC test? So is it screenshots, Siri, accessibility audit, Xcode Cloud, launch environments, or assertions? A function. I think there's some grammar issues here, but like I wrote this at 1 AM, okay? Which method allows you to convert a completion handler to an async function?
It does is, I think it has a parameter in the closure, and if you set that parameter, it will just return it back. Yes. You can just read the Hacking with Swift article. Don't quote me. Okay, so which method allows you to convert a result type to a throwing expression? So a result type is the enum one, the cool new like switch result. See that thing, the small little screenshot there. The one where you can switch with the success and the failure. So there is a way to convert that into a try catch. So is it throws, value, success, get, publisher, or failure? So it is actually get. So I don't think you can actually name the function throws because it's a reserved keyword. But if you take a look over here, so see now I have to bring like evidence every time I do this. So this is the result type. So it's basically an enum with success or failure. And over here, get actually converts this into, basically it just returns the success value in a throwing expression, and then it'll return the error after that. Okay. Next. Wait. No, status one. Wait. Okay, congrats, Newton. Oh no, sorry, Temco. Okay. Multi-select. Which of the following is new with iOS 17 in SwiftUI animations? So is it completion handlers, face animators, transition, match geometry effect, keyframe animators, or symbol effect? This quiz has a lot of completion handlers. Okay, so it is completion handlers, face animators, keyframe animators, and symbol effects. So now you can run code when an animation completes by specifying a completion condition, and then you can be like, when the element is removed, then you run the code. Transition and match geometry. Match geometry effect is, I think, 2 years old. Transition is very old. Okay, so Newton is still on top. Okay, multi-select. Which of the following technologies are unavailable in Vision OS? So which of the following technologies you cannot use in Vision OS? Is it core motion, camera, device management, haptics, pencil kit, or health kit?
Yeah, exactly. How do you use an FNC in the way?
That's crazy. So it's actually core motion, camera, and health kit. Pencil kit is supported, so they have this cool thing where you can use your finger like this and you can draw. So that's how pencil kit works. Health kit is not supported, camera not supported. Camera is mainly a privacy thing along with core motion. Device management interestingly is, so you can actually MDM your Vision Pro. I don't know why. Okay, so congrats Newton. So multi-select. Which of the following are Apple Swift certifications? What? Any questions? So is it App Development with Swift Level 1, App Development with Swift Level 2, Apple Certified Trainer App Development with Swift, App Development with Swift Certified User, App Development with Swift Associate, App Development with Swift Pro Max? Swift Pro Max? It's Apple, you don't know.
How is certified?
So it's App Development
Level 1, they never ever came up with a level 2 before discontinuing level 1. Apple Certified Trainer, App Development with Certified User and Associate. They're actual real certifications you can take. You can like pay money for it, I think. I don't know how it works. Okay, congrats Newton. So one last question. When is iOS Conf SG 2024? If you're wondering, this is the cropped image. Right below that is actually the answer. So is it 4th to 5th gen, 11th to 12th gen, 18th to 19th gen, or 25th to 26th gen? Okay, so it's 18th to 19th gen. So if you got it wrong, please remember, because yeah, very important, you should attend. Okay, so let's see the results. So third place, Open All. Second place, Sirum. And first place, Newton. So where's Newton? Okay, do you wanna come up front? So, oh yeah, we forgot to mention this, but there was a prize. Oh yeah, do you wanna come and claim your prize? Apologies about the safety hazard. Okay.
On your side?
Yeah, just full.
Is it okay?
Yeah.
and there is no cable long enough to stretch over.
So thank you to all the amazing speakers. So just go.
Okay. Okay, fine. Okay. Can you hold this for a sec? Give me a second.
No, I'll just continue. Okay, so as you would have heard just now, tickets are now available for iOS Conf SG 2024. So they are 18th to 19th January. If you got it wrong, take note. Very important. Okay?
Do you have a QR code?
No, I'll just continue.
Okay, I'm gonna continue. Yeah, so there's one more thing. Apple is holding a special event. Well, it's a virtual event. It's a call. It's inviting you guys and anyone else you might know to hear more about the successes, challenges, leadership experiences of world-class leaders at Apple in Asia Pacific. There's a lot of big names, as you can probably see from the slide: Isabel, Richard, and Iris. And it's on the 2nd of November, 2023, 4:30 to 5:30 p.m. Singapore time. It's on WebEx, and you can scan the QR code right now to register. There is a deadline. You need to submit by 25th October, 12 p.m. This form. If you want, you can take a photo and then sign up later if you want. Okay, as for the final thing we would like to talk about, iOS Conf Singapore 2024 tickets are out. They've been released. You can go and buy them right now at the QR code over here, 18 to 19 January, please remember that. Yeah, the Apple special event, as I mentioned. And we also invite you to speak. We are always looking up for speakers, and please approach Melvin, Melvin at the back, Steph, and Rina. Or the QR code is not there, but you can also go to Discord and just approach us and tell us what you want to talk about. Yeah, we're always looking for speakers. Thank you all so much for coming today. Thank you to our speakers once again for having incredible talks. It's very amazing. And of course, lastly, thank you to our host, SMRT, for holding us at this wonderful event. Thank you everyone for coming. Wait, we do need to take a group photo. So just chill. We know you want to go home.
So what's the logistics of this group photo?
Chill.